LCycle is a free online tool for comparing the life cycle cost of the property with the funds available for capital repairs and replacements. The tool walks you through inputting some basic information that should be all readily available pre-development, and then shows the estimated cost of the property's capital needs each year compared with the estimated replacement reserve balance. This provides an advanced window into the adequacy of the property's reserves. Is there a shortfall? How big is it? And when does it occur? So why did we develop this LCycle, and why should you use it? One of the early findings of our research into property long-term viability was that many properties have replacement reserve funding that is not adequate to fund their likely capital needs. The cost of major repairs and replacements such as appliances, floor coverings, heating and cooling systems, roofs, sidings, and windows. In our sample, a few properties' reserves were likely to run out of money at year 10 or earlier, and starting at about year 15, many properties' reserves became inadequate. 7% of the properties in our sample had replacement reserves that were adequate to cover a full 15 years of estimated capital needs. During our research, Charlie and others from the initial research team met periodically with an advisory panel of housing research experts, policy experts, and experienced practitioners. They believed that this sort of early and quick analysis of expected life cycle costs and reserves was a missing piece that could help practitioners engage in longer-term planning and adjust for potential problems. They encouraged us to make the reserve adequacy analytic tool available to practitioners. The software you will see today is the result. Now I will hand it over to Charlie to dig deeper into the tool and show you how to use it.
Thank you, Maya, and thanks everybody for attending today. I'm Charlie Wilkins. I started in the property management business in the late 1970s and very soon concluded that all of our replacement reserve accounts were pretty seriously underfunded. For my entire career, I've been an advocate for better capital needs planning, and I think that the LCycle software is an important new tool for capital needs planning. Working with the Center for Housing Policy, I led the software development team for LCycle and also participated in the research project that led to the creation of LCycle. Maya will continue operating the computer today as we tour through the software. Using information about a property's reserves, physical configuration, cash flow, and debt service payments, the software estimates the likely long-term capital needs and compares those needs to the likely reserve balances each year for 50 years. If you have questions during the presentation, please enter them using the question box on the control panel. As Maya said, I'll generally stop and answer questions as they come in. First, we'll demonstrate basic capabilities of the software using a sample property that we'll create during the webinar. And then we can go into fine points after that. The software is designed so that you can get useful results with only a few pieces of information, and it's also designed so that you can control the underlying calculations if you want to dig deeper. When you go to the website, the first thing you will see is the screen that's about to appear in front of you. This is a software overview for first-time users. So this tells you, what the software is designed to do, and there is a software overview button in the middle, and if you click that, then it will pop this window up, which tells you a lot more. So this gives a chance for people to move in quickly and just start using the software, and also a chance to learn some more. There is also a blue toolbar on the right-hand side that shows our privacy statement. None of the information that you upload to this website is going to be shared with anyone. We maintain the information here as a convenience to you so that you don't have to re-enter it the next time you come back. But we don't do any analysis with it. We don't use it. We don't give it to anybody else. So it's a pretty strong policy statement. Starting from this screen, there are two options in the top right. One of them is for a existing user to sign in. The other one is for a new user to register. Now, Maya has already signed in, so we're already registered, so we're going to go directly to the sign-in page. When you register, you'll select a password, and that's just so that not just anybody can masquerade as you. Once you've signed in, you'll end up at the properties screen. If you have entered properties previously, they will all appear here. If not, as in the situation we have, you can click on the Now word, and it will give you a chance to create a property from scratch. Today we'll be entering a new property, and Maya is going to invent a property name. And this particular property is going to be in the southeast in a relatively low cost area, and this will be an acquisition rehab property. In other words, this is a property that was built some time ago, and we're going to buy it, rehab it, and operate it going forward. The next feature is the unit mix of the property. So in the row that Maya is working in at the moment, she's going to enter the number of units of each type. A non-revenue unit means a manager unit or a unit that's used as an office or a unit that's used for storage. So this is a 101 physical unit property with 100 of those units being revenue units rented to tenants. They're all 2 bedrooms. They average 900 square feet. Throughout the software, there are little blue circles with question marks in them. If you hover over, it's okay. If you hover over one of those bubbles, then you get additional text. And we built these after doing extensive testing of the software during initial development, and we've included bubbles in most of the places where users might have questions. And by the way, as you use the software, if you think of things that would make it easier for other people, we'd be delighted to hear from you and to get your feedback so we can improve the software in the future. At the bottom of the screen are navigation buttons. If you click any of those buttons, it saves your work. Maya just clicked the Go to the Next Screen button, which does the obvious thing. And this leads to the Building Systems screen. This is an acquisition rehab property. So that first thing we need to enter is the year when the property was built. So let's enter 1972. The next thing we have is the opportunity to say which building systems are being replaced during the rehab. What we see most frequently, particularly in 9% tax credit transaction, is that there's a fairly heavy level of rehab. So for purposes of our example, we're going to leave this as if all of the major building systems are getting replaced during the rehab that we're planning. But if, for example, we were going to do everything except the roofs, then Maya could click and select Not Replaced During Rehab. So the way this property is configured right now is everything except the roof is being replaced. Now let's take a look at the exterior stairs category. What if your property happens not to have exterior stairs? Well, then you can select Not Applicable. And that will cause the software not to calculate any replacement costs for exterior stairs. And as you can see, you can customize this to the specifics of your particular property. And let's move on from there. Now we're going to have some information about what we call hard debt, by which we mean mortgage loans where the payment has to be made every month whether there's cash flow or not. And Maya's going to be entering information about the loan. You'll notice that there are navigation buttons at the top right of the screen. And these will let you move among the main screens inside the software. So later on, if you wanted to come back to this page, you could click on the square toward the top right that says hard debt, and it would bring you back to this sheet of the software. The software calculates the monthly principal and interest payments, and when you're using the software yourself, this is a good point to check back to your pro forma or other information to make sure the software is coming up with the same number that you're expecting. Similarly, if this is an FHA insured loan, the software will calculate the annual mortgage insurance premium. And then the total between principal, interest, and MIP we call debt service, and that's the number at the bottom of the screen. Now when we go to next, we will end up at the replacement reserve screen. And Maya's going to enter some information about this particular property. And here we're using a property that's fairly typical for the way affordable housing has been developed in the past. The replacement reserve starts life with no money in it. That's what the zero means on the top line. And we're depositing about $300 a unit a year into the reserve going forward. That's sort of an industry rule of thumb. Everybody knows it's too small, and LCycle will tell us in a bit just how much too small that is, and we'll see what the consequences are. After replacement reserve, we then have a chance to say whether we're in a low, moderate, or high-cost area. We're going to enter low-cost areas. That would be consistent with Macon, Georgia, which is where our hypothetical property is located. You'll see there's a blue box that says I want to enter my own replacement costs. We won't do that at the moment, but you could do that if, for example, you think you have better replacement cost information than the software does. And if you choose that option, then you would choose low, moderate, or high cost at the starting point, and then you could make edits from there. And you can save that set of replacement costs in your profile in case you want to use it in a future session. And we'll click go to the next screen and move along. Now we get to the cash flow screen. Maya's going to be entering revenue and expense information as we go forward. And you'll notice that the line called calculated net operating income is going to be updating as she's doing that. You'll see out to the right, the software is giving us some additional information. For example, it translates the gross potential rent into dollars per revenue unit per month. It translates the calculated debt service into a debt service coverage ratio. And you can use these metrics as you're entering data in the software to verify that it's coming up with numbers that make sense to you. And again, you want to check your data entry to make sure that the numbers you're putting in are the same ones you intended to put in. The last thing that Maya entered is first year of stabilized cash flow. So this is the first year when the property will be through rehab, through lease up, and producing a normal revenue stream. And we've entered 2007 here. Okay, let's go back to the economic assumptions just for a moment. Okay, well, we're going to select the garden apartments set This particular screen is a little bit complicated, and we can come back to that later, but basically it lets you use one of the 4 standard assumption sets that the software comes with. It lets you create a custom set using one of those as a starting point, and it lets you use a previously saved custom set either with or without changes. So you have a lot of flexibility to choose your own inputs about inflation and interest rates and things like that that help drive the results of the software. So Maya's going to save that, and we'll go back to the cash flow screen, which is where we were. And the final thing at the bottom is what type of rent increase are we looking for? So if this were a Section 202 property, or if it were a rural development Section 516 property, we might select the second option, which is adjust rents annually based on budget. But for purposes of this demonstration, we'll select the first option, adjust rents annually using an inflation factor. So this would be consistent with a low-income housing tax credit property or a property with project-based Section 8. And we're now going to move on to the next screen. And what's happening now is the software was calculating this graph that now appears in front of you. This is sort of the punchline of the software. And we're going to go through this a little slowly so you can appreciate what you're seeing here. You have years on the horizontal axis. So it goes from 2005, which is the year of rehab, through 2055, which is 50 years later. The vertical axis is dollars in millions, and we have 3 lines. The green line is the cumulative amount of money that's been deposited into the replacement reserve. So you'll remember the replacement reserve started life with no money in it, and we're depositing a consistent $300 a unit a year or so, and with that amount actually is increasing for inflation each year. So as you would expect, the green line slopes up to the right at a more or less constant rate. So over the 50 years, about $2 million gets deposited into the reserve. So far, so good. The next line is the blue line, and that's the cumulative capital needs. So this would be, in the early years, carpet replacement, a few water heaters, later on refrigerators, air conditioners, after that roofs, furnaces, resurfacing the parking lot. And about year 30, then you would get windows and siding. So what you're seeing is that blue line rising in a lumpy kind of way, rising relatively slowly until between year 20 and 30, where it starts to accelerate, and then in year 30 where it hits what I like to call a triple witching hour. Because in year 30, you get the third replacement of 10-year systems like water heaters. You get the second replacement of 15-year systems like refrigerators, and you get the first replacement of 30-year systems like like siding and windows. And that's that big, almost vertical jump at year 30. So what you see here is that the green line is enough, or just barely enough, through about year 15 and maybe even into year 20. But after year 20, the reserve becomes more and more inadequate. And so if you look at the gap between the green line and the blue line, we're about $500,000 to $750,000 short. By year 30, we're about $2 million short at year 30, and it stays about $2 million out of balance from then on. The red line is the deficit, so that's the difference. What you like to see is the red line staying at the bottom of the screen and never going above the horizontal. So we have a small deficit in year 15. It goes back down to 0 by about year 20, and then it creeps upward. It jumps at year 30, and then it goes up at a fairly alarming rate after year 30. So what this means is, in the context of this property, the normal industry rule of thumb way of funding reserves will just about get you through year 15, but is increasingly inadequate thereafter. So what is one to do if your objective is for the property to be viable for many more than 15 years? Well, there are a couple of things you can investigate with the software. You'll see 3 gray buttons over to the right-hand side of the screen toward the top. What we've been doing is what we call the base case. We're only relying on the replacement reserve. Let's take a look at refinancing, which is the third of the buttons. What this is going to do is it's going to assume that the property's first mortgage loan is refinanced a couple of years before the first deficit occurs. So that would be year 13 or so. Now look at the green line. It jumps upwards right at year 13, and it looks like our refinance brought in something like $750,000. And that is sufficient to cover the property's capital needs until we get to year 30. And once we get to year 30, we're in trouble again. And we're in increasing trouble thereafter. So thinking about, again, industry standard reserve funding and a normal sort of property, the reserve alone might get you through year 15 if you're lucky. The reserve plus a refinance might get you through year 25 or so if you're lucky, but you still got a problem after that. So let's try the third scenario, and this is what we call the cash flow scenario. So instead of refinancing the first mortgage loan, we leave it in place. We pay it, continue to pay it down. It's a 30-year loan, and so it's paid off at the end of 30 years. And in addition to that, all of our cash flow, instead of going into the pocket of the investor, goes into the replacement reserve account. Now you see the green line going up at a very rapid rate, and it goes up even faster after year 30. Now the reason for that is it's a 30-year mortgage loan. The mortgage loan is paid off after year 30, and there's much more cash flow as a result. So this tells us that in the context of this property, the property would be fine if we used a big chunk of the cash flow for the first 30 years and some of the cash flow after that. We could cover all the capital needs and still have some cash flow to distribute to the investors. So that's 3 different ways of looking at using the internal resources of the property. But let's suppose we decided that this property was just too thin. Let's say that we had an objective of having the property viable for 50 years without relying on cash flow or refinancing. Then there are a couple of things we could think about. One of them is to have a lower first mortgage amount. It might work to have a first mortgage that matures faster, so a 20-year or 25-year loan instead of 30. The obvious change might be to have a greater annual reserve deposit. Another obvious change might be to put more money in the reserve at the beginning. Now, which of those is the best for any particular property is going to vary, and it will also depend on what resources are available and what the development team would think would make the most sense. So we're going to come back to this and try some of these alternatives a little bit later. I wanted to demonstrate a couple of the features of this screen to you before we did that, however. At the bottom, there are two links. The first one is View Data Inputs. So this is a place for you to see all the information that you put into the software. This is actually a PDF file that you can print or save down to your desktop. And it's a really useful way of keeping a record for yourself about what information you put in. You can also use it as a debugging tool. In case you think you may have made a mistake, you can print this out and then compare it to your notes and see if you put in the same information you intended to. So that's the View Data Inputs feature. The other feature is View Data Exports. And what this is going to do is it's going to open up a Microsoft Excel file. And this is designed so that you can see the actual numbers that underlie the graph. It's set up so that you could save it to your desktop. You could actually feed these numbers into a spreadsheet of your own and do your own manipulation with the numbers. And you could save it as a record of the results you got from LCycle. So these are a couple of features that we built into the software that we hope will be useful to you if you want to take the analysis to another level. So we're going to go back to the graph now, and we're going to click on the base case button. So we're going to go back to the scenario where we're only using the reserve for replacement. And we'll wait a little while it is refreshing the graph. There it is. So let's suppose that we wanted to make a change to the replacement reserve funding. So let's find the navigation buttons up at the top of the screen, and let's click the replacement reserve. So that takes us back to the beginning. And now what we're going to do is we're going to put an extra $1 million in the reserve at the beginning. And now you will notice at the very bottom of the screen there's a new link that says, I'm done now, show me the results. So once you have entered all the information that LCycle needs, it will show you that option so that you don't have to go back through the remaining screens in order to get your revised punchline. So in a moment, we're going to see what happens when we put that extra $1 million in the reserve. As you would expect, the green line now starts out at $1 million. It still rises to the right at the same steady and relatively slow rate that we saw before, but now the reserve is adequate up until just about year 30. It still runs into a problem at year 30, and it's still a couple $1 million, maybe even $3 million underfunded at year 50. But we did, by putting that extra $1 million in the reserve at the beginning, we did push off the day of reckoning from about year 15 to 20 to about year 25 to 30. Now let's go back and try something different. We're going to go back to the replacement reserve screen, and instead of putting an extra $1 million in at the beginning, we're going to go back to our zero beginning balance, but we're now going to go with a $50,000 annual reserve deposit. So this is more like $500 a unit a year instead of the industry rule of thumb, $300. So we're going to go back and let LCycle regenerate the graph. And what we should see now is the green line will start at 0. It will rise to the right, but it will rise faster because we're depositing more money every year. Here also, just like adding the extra million, doing a greater annual deposit staves off the day of reckoning to about year 25 or 30. But you'll notice that the deficits after year 30 persist, but they're smaller. So other things being equal, it's more powerful to increase the annual reserve deposit than it is to put money in the reserve at the beginning. And that's sort of a rule of thumb that we observed through running a lot of properties through this software. But we're still not there yet. And I'm a little bit worried about increasing the reserve deposit without checking to see whether I have cash flow available. So let's go back to the cash flow screen and see how we're doing. And if I look to the right of my calculated debt service line, I see a 1.03 debt service coverage ratio. Now, if you come from a lending or real estate finance background, you will instantly know that that is too small. And what it means is there's $1.03 of net operating income for every dollar of mortgage payment. And that's not enough margin of safety to make a lender comfortable or to make an owner or a property manager comfortable. So if we're going to use this bigger reserve deposit, something has to give. And probably what this means is we're going to have to go back and borrow less on our first mortgage. So let's go back to the hard debt screen. And instead of $2 million, let's change to $1.8 million. This will reduce our annual debt service. And we can go to the next screen. And let's go to cash flow now. And now we're up to a 1.15 debt service coverage. So that's getting into the more comfortable zone. It's a little bit thin, but it's in the comfortable but thin range, whereas 1.03 was in the thin and uncomfortable range. Let's see what the graph looks like now. It should be about the same as before. But at least now we have a little better cash flow margin in the property. So LCycle is regenerating the graph at the moment. Here it comes. And this is pretty much the same result that we saw before. The green line starts at 0, slopes up to the right more rapidly than before. We still have deficits after year 30. They still increase between year 30 and year 50, but it's not as bad as the scenario where we were putting an extra $1 million in at the beginning and continuing with the small annual reserve deposit. Now suppose we decided we were going to do what we just said and we were going to refinance the loan just before our first deficit. Let's see what that looks like by clicking the refinancing scenario button. And what we're probably going to see is the green line jumping up at year 30. And here we go. It looks like the refinancing raised almost $2 million. And that extra $2 million or so that went into the reserve in about year 27 or 28 is enough to cover all the capital needs through year 50. So this is an example of trying different scenarios with the same property to see which one works the best for the development team. And in this case, because the development team was trying to do a 50-year sustainable property without going back for more tax credits or more home funds or more CDBG funds or more state housing trust funds during the 50-year period, this scenario looks pretty attractive. It solves all the problems. It doesn't leave a lot of money on the table, but it looks like there's at least some wiggle room. And so the development team could look at this and think that maybe this is a viable way of pursuing a property that's long-term sustainable rather than one that's going to blow up financially after about year 15. Now that you've seen the basic capabilities of the software, we want to go back and take a look at some of the additional features. And the thing I'd like to show you next is how the key economic assumptions work. We built the software so that you could control the underlying parameters in the software. Let's go inside the standard garden apartment set and have a look. And if you click on any one of the assumption sets, you will get this PDF file. You could save this to your desktop, you could print it, or you could just view it on the screen. And this shows all of the economic assumptions that drive the LCycle software. And in this way, we hoped to give users pretty much full control over the sort of outputs that they would get. The first set of assumptions have to do with inflation and trending. The first one is the most important one. This is the outlook for general inflation. So you could think about this as the outlook for a 50-year consumer price index. And the next few show trending rates in relation to general inflation. So we're assuming that gross potential rent will inflate at 0.5% slower than general inflation. So that is, general inflation is moving at 2.5% a year. The rents will move at 2% a year. This is relatively consistent with the way lots of people do underwriting for affordable rental housing. The other trending factors are set to be at the rate of general inflation. So this means that other income, such as income from laundry or bounced check charges or late charges, will go up at the rate of inflation. Expenses will go up at the rate of inflation. The annual reserve deposit will go up at the rate of inflation. And what it costs to replace a refrigerator or a roof or a window will also rise at the rate of general inflation. The last two have to do with interest rates. The next one is the interest rate you expect to earn on the replacement reserve. And this minus 1% means that in a 2.5% inflation environment, we're expecting to earn 1.5%, that is 1% less, on the replacement reserve. And if you were more conservative, you might, at least in today's environment, enter something like -2, meaning you're getting almost nothing on the replacement reserve, which is sort of the way things are at the moment. But what you're really trying to do here is to estimate what the typical inflation rate or interest rate is going to be over the next 50 years. So you want to be careful not to let today's reality sway you too much. What you're really looking for is a long-term average. And if you don't know where to look for things like that, find a friend who's an appraiser, or find a friend who's a lender, or find a friend who's a banker, and ask them about it. Or call up your local university and speak to somebody in the economics department, and they can tell you websites where things like this are found. You can also look at the website for the Office of Management and Budget in the federal government, because the President's budget for the United States every year includes a long discussion of expected economic assumptions over the next 10 years, and a lot of people use that as a starting point for assumptions like this. The next set of assumptions have to do with refinancing. So we've assumed in our standard assumptions a pretty conservative set of refinancing assumptions. We've assumed that the lender is going to require $1.50 of NOI for every dollar of mortgage payment. That's what the 1.50 debt service coverage ratio means. We've assumed the lender won't loan more than 75% of the value of the property. And we've assumed a 7% interest rate and a 25-year loan term. You can probably do better than that today. And the question is, what do you think you will be able to do on average over the next 50 years if you refinance a property like this? We think this is a pretty good set of assumptions for the next 50 years, but that's largely guesswork, and you may have a different guess than we do. In which case you could do a custom assumption set and put your own set of assumptions in. The next set of assumptions are about the expected useful life. That is, for example, for a roof, how soon after you install the roof do you expect to have to replace it? So this is the theoretical life of the next roof replacement you do, or the next set of exterior stairs, or the next replacement of windows. So this is not so much the life you actually got out of the current components or out of the original components. It's what you expect to get for any new components you install during rehab or construction. These are largely consistent with useful lives that everybody in the industry uses. They're largely consistent with the Fannie Mae guidelines, which is the most common benchmark that you see. But it may be that you're intending to use a product that has an especially long life. For example, you might be intending to do a metal roof or a roof with 50-year shingles or something like that. You could go in the custom assumption set and use a longer useful life for roof if you are going to be using an especially long-lived roof product. Let's take a look further down. The next set of assumptions are a little more complicated. These are the coefficients or ratios or parameters that the software uses to translate the number of units and the square footage of the units into how much siding is there, how much roof area is there, how many windows are there, etc. And in the software, there are bubbles. When we get to the input area, there will be little blue question mark bubbles that will explain each of these. And we're also in the process of adding a set of frequently asked questions to the software that go even deeper. So if you are one of those users who likes to get down in the weeds and to move the levers and twist the valves and turn the knobs, you can do that in this software, and the capital E's parameters is one of the main places where you can change the way the outputs come out of the software. Finally, at the bottom are a set of assumptions that have to do with how the software calculates the future market value of the property for refinancing purposes. And this is all appraisal terminology, basically. Capitalization rate is the relationship between the net operating income property and the value. 9% is a pretty conservative cap rate. That is, it results in a relatively low market value. Typical apartment properties command lower than a 9% rate at the moment. The question is, what will be a typical average rate for the next 50 years? I happen to like that number for the next 50 years, but I'm a little bit conservative, and maybe you have a more aggressive view. The two lines down, the one that says CF test, that's the cash flow test. So this tells the software when to start depositing cash flow into the replacement reserve. And our standard assumption is start 5 years before the reserve is going to run out of money. And you may have a different assumption. The next line, the refi test. If you're selecting the refinance scenario, this tells the software, assume that the refinance happens 2 years before the reserve runs out of money. And if you wanted to change that, you could. So let's move out of this little PDF file, and let's see, we'll look at the test assumption set, and this will, and let's do use and make changes. So this means we're selecting a custom assumption set, and we're going to use it, and we're going to make changes. So let's do a save. And now we're into being able to make changes to the individual economic assumptions. And as you remember, the first set has to do with inflation and interest rates. So we could change any of these assumptions we wanted to. So we talked about replacement reserve interest rate earlier. Let's say we think that the current situation of almost no interest earnings is going to continue, and let's do -2 here, which means in a 2.5% inflation environment, we're going to get a 0.5% a year interest income on the replacement reserve. And let's do save or go to the next screen. Here's our set of refinancing assumptions. We'll leave those alone at the moment, and let's go to the next screen. Here's our useful lives. Let's suppose we're using a long-lived roof product, and let's go to 40 years. And we'll go to the next screen. And then here's our capital needs parameters. And you'll see there's blue bubbles on the screen, so if Maya hovers over the one for roof, then you'll see a discussion about what this parameter is and what impact it has on the amount of roof area that the software calculates. And let's go to the next screen. And finally, here were basically the appraisal-based assumptions that we talked about last. So we can now go to the next screen. We've made some changes in the economic assumptions. Let's go see the results. This isn't going to change things very much because we only made a couple of changes and they weren't big ones. And LCycle is now regenerating the graph. And it looks virtually the same as before. So the big change we made was we knocked the percent off the interest earnings in the reserve, and it turns out that didn't make much of a difference because we also lengthened the life of the roof. And that smoothed out the capital needs a little bit, and it pushed some of them out from year 30 to year 40. So on balance, those two changes pretty much canceled each other out. So that's an example of how you can use the software to do what-if analysis. Another thing you might do is you could say, well, you could go in and change some of the assumptions about replacement costs and say, I'm going to use more expensive replacement materials, but I'm going to use things that use less utilities. And so I'm going to have an especially efficient air conditioner, for example, and I'm going to install water savers, and I'm going to use an efficient boiler for my hot water heating and so forth. And now you might get a lower utility cost, which would mean less operating expense, and which would mean that the property would perform better. So that would be another example of things you could control inside the software. I would remind you that we're open for questions at all points, and the way to do that is with the questions box in your control panel. The control panel is to the right, and you may see, if you don't see a control panel, you'll see a little arrow pointing to the left, and if you click that, that will expand the control panel so you can see it. And then you could go to the questions box and type in a question. This pretty much ends the demonstration that we wanted to do, and we wanted to see now if there were things you would like to drill down on, or things you'd like to see again, or questions you'd like to ask about how the software might be used, or how we developed it, or anything else that comes to mind. And we'll be monitoring the questions box to see what shows up.
We have a question here about how closely linked to the location of the property, city and state, to the useful life cost assumption. So, Charlie, can you say something about the location linkage?
Let's go back to the property screen, and in this software, the way you do that is the little house icon. That's the home of the software. So if you click that from any point, you'll come back here. Let's go ahead and click on Webinar Test, and this will bring up the Update Property screen. Now, we put in Macon, Georgia. That is just something that's there for you to help you remember. It has no impact on the software whatsoever. What does have an impact, however, is something we're going to see on the next screen. So let's go to the next screen. And one more. And one more. Replacement reserve. Here we go. You see in the replacement costs section of this screen, you have three choices: low cost, moderate cost, high cost area. This is where you tell the software whether you're in Macon, Georgia, or Philadelphia, or San Francisco. Those might be examples of low, moderate, and high cost areas. And if you have really good information about replacement costs, you can enter your own. So let's click on that right now. I want to enter my own replacement costs. And let's base it on the low cost area. Now you get a chance to actually drive the key assumptions about what it costs to replace things. So here we have, for example, Windows. The place where these numbers come from is from one of the leading capital needs assessment providers in the industry. We had them help us come up with good typical costs. And by the way, these are stated in 2009 dollars. But let's suppose that you're planning to use not traditional builder grade windows. You're going to use a more efficient, higher cost window. So let's change that to $600 each. And then what that will do is when it comes year 30, which is time to replace the windows, you will see more replacement costs coming into the software, and the blue line will jump a little bit higher in year 30. And similarly, you could make changes in the others. Let's suppose with air conditioners, instead of $806 each, we're going to spend $1,200 each, but we're going to get a much more efficient air conditioner. And then let's also assume that for the roof, as we already said we were going to go with a 40-year roof, let's assume that's going to cost us $175 instead of $134. Okay. And now let's just go to the next screen. And I'm done now. Oh, wait a minute. Before we do that, I want to change the operating expenses. Let's go to $425,000. Let's assume we're going to drop our utility expense a little bit. And let's go to the end. If we're using more efficient components, we should have lower utility costs. And of course, I'm guessing at the numbers as we're doing this. If you were doing it on a real property, you would have real numbers that are based on advice from your development department or your lead maintenance person or your air conditioning contractor or somebody like that. So here we have results, and now we're seeing a little bit of a deficit at year 50. So what that means is the changes we made that drive up cost just slightly outweighed the $25,000 reduction in utility cost. And so you can see from this that decisions about more efficient components have everything to do with how much utility cost you think you will get by spending more for the air conditioner or the hot water boiler or whatever. And in this case, we were spending a lot more on the roof to give it a longer life. We were spending a lot more on the air conditioner to make it more efficient. And we only decided that we would only drop utility costs by a relatively small amount. So maybe that would be a place to go back and sharpen the pencil and see whether there's a better set of changes we could make. So there again, that's an example of how you could go into the depths of the software, change the fundamental drivers to more closely match what you think you're going to do with your property. Now, I should say at this point that this is not a substitute for a professional capital needs assessment. Because there's a lot you get from having a real expert go out to your site, and look around and talk to you and brainstorm and ask you questions and talk to the maintenance staff and say, had you thought of this? Or this might be a good time to use a geothermal heat pump. Had you thought about that? Or have you thought about converting from individual meter to master meter for this utility because you get this huge break in your utility cost? Or were you thinking of changing from master meter to individual meter because you would get much more efficiency because tenants would use less? Those kinds of conversations aren't going to happen with you putting numbers into this software. But, as you can see, in a half hour or less, you could get fairly deep in some very meaningful analysis of whether your property makes sense financially over the long term. And it would position you really well to have additional discussions with your development team, with your lending partners, with your other funding partners, to see if there's a better and more sustainable way of configuring the property financially. And this is sort of in your interest as property managers, and I'm speaking now as an ex-property manager and ex-NAHMA president. It's always good when the properties they give us have a more adequate reserve from the beginning and are more likely to be able to pay for their roof replacements and so forth, rather than 20 years from now us having to go back to the leadership in the company and say, our reserve is running out of money, we have a problem. So I wanted to see whether there were any final questions that anybody wanted to ask. And I wanted to, in the meantime, reiterate one thing that we said earlier. We're continuing to enhance the software. We're very interested in feedback from all of our users. And as you use the software, if you spot things either that don't make sense to you or that need additional explanation, or wouldn't it be great if I could do this, or wouldn't it be great if it showed me this. Let us know, because we do have ability to make those kinds of changes within limits, and we'd be delighted to make the software more useful to you and people like you. So Maya is now showing our ending slide, which shows you several things. One is that at the web address that's listed there, we have archives of prior webinars. We have policy papers about life cycle underwriting, and there are links where you can send comments to the National Housing Conference and Center for Housing Policy. There's a Twitter link right there on the screen. And as I said, we would be delighted to get feedback of all sorts from you or from other folks. And if you know of other people who might be able to use this software profitably, by all means let them know. And if they would like to see your prior webinar, we have them on archive right here at the web address on the screen. And at this point, I'm going to turn it back over to Maya to wrap up.
Thanks, Charlie. And I'd like to also apologize for the echo problem we were having at the start. I think our phone setup in the room was creating a little bit of a feedback loop internally, and I hope that's been resolved. So thanks, Charlie. And if you do have other questions, we would be glad to take them, or you can interact with us through the nhc.org/LCycle. There's information there about the modeling tool, the webinar resources from prior webinars are archived, as well as additional papers that discuss the policy and practical implications and the cost comparison there. So thanks to NAHMA for allowing us to present the LCycle information to you, and thanks to all of our participants today, and especially to the MacArthur Foundation for its generous support of this project. The full set of materials, as we mentioned, are at nhc.org/LCycle. And we'd like to keep hearing from you after the webinar is over to help us continue improving the tool and ensuring it's useful for your work. We've already made modifications based on information that has come in from users about how to make it more accessible for your needs. So continue to send us those at chp-feedback@nhc.org, or you can post your questions in our housingpolicy.org forum as well, which can be found at forum.housingpolicy.org if you'd like to open them up to a sort of wider crowdsourced audience.